All right, guys. So today, what we're going to do is we're just going to go over some of the notes from moisture in the atmosphere that I gave out on Friday. I told you guys to look at. We're just going to go over a couple of things that I thought were important for you guys to grab from it. And then we're going to do a couple of practice problems towards the end, okay? Also, just remember report cards go out tomorrow, so I'm not going to assign anything on Google Classroom. I'm going to post some new stuff tomorrow on it. I'm going to give you guys the rest of the day to try to get as much stuff in as you can, okay? Besides that, can you guys hear me all right? So really quick, the moisture in the atmosphere, it kind of goes over our water cycle that we went through a couple of weeks ago before we were home schooling. All right. So basically, with the water cycle, the main part of it is that the driving force is the sun. If there was no sun, there'd be no water cycle. All right. There'd be no life on Earth as we know it. Okay. The sun is the driving force behind the water cycle. All right. So basically, some of the things that we need to get out of the water cycle is it's all about, with respect to weather, is evaporation, because we need to get moisture and water vapor into the air, okay, into our atmosphere. And remember, most of our weather, pretty much all of it, happens in the troposphere, which is our bottom layer. So to get water into the atmosphere, okay, we need to have evaporation. So there are 4 different things that affect evaporation. All right. And they're all in the slides, but I just want to go over it really quick. So when temperature increases, evaporation increases. Basically, the warmer it gets, the hotter it is outside. That's how quick stuff evaporates. All right. Think about it over the summer. If you spill like a drink on the pavement, it usually evaporates very quick. It dries up. All right. So that's the first one. The next one is surface area. If surface area increases, evaporation also increases. That's if you have a giant pool in your backyard, it's going to constantly be evaporating. Whereas if you have a glass of water on a table outside, okay, there's less surface area on that glass of water. So as the surface area expands, gets larger, evaporation, okay? Now, air humidity, all right? As air humidity increases, evaporation actually decreases. And we are going to talk about what humidity is in a second. And then the last thing is wind speed, okay? As wind speed increases, evaporation also increases. So for all these right now, they are all increasing, and evaporation always increases except for air humidity, okay? So air humidity is the measure of the amount of water vapor in the air. Okay. So if there is a lot of water vapor in the air, there's not room for more water vapor. So that's why evaporation, nothing can evaporate after that. All right. Hey, what's going on? This is actually 8th grade. The other video for 7th grade is on at 12, but that's on the website if you want to look at that. Okay. But I'm glad you're on. So now we're going to get into relative humidity, okay? So that's the percent of water vapor in the air compared to the maximum amount of air can hold, right? So basically what this means is warm air can hold more than cold air, all right? That's why over the summer you have those really hot, humid days because there's a lot of water vapor in the air. So what I want you guys to do is I want you to turn to page 12, okay? In your Earth Science reference table. So if you go to page 12 in your Earth Science reference table, you'll notice there's 2 charts, okay? You got dew point and you got relative humidity, okay? And we're going to be talking about both of those in a second. Now, if you go down to your slide to number 23, we're going to use one of the weather instruments, the psychrometer, okay? I'll send you the Bill Nye thing at the end of this, all right? Just give me a second. I'll be done with this in 20 minutes, all right? So a psychrometer, okay, used to measure the moisture content in the air. So how the psychrometer works is that they have two bulbs, okay? The picture's in the slide, so you have a wet bulb and a dry bulb. What you're going to do is you're going to find the difference in both of those temperatures after you spin them around. Okay? I'll look into it, all right, Jose? So the dry bulb, all right? So for this in the slide, I'm just going to go over this, all right? So you guys can see me. So for this, we're going to find, let's say we're going to find the dew point of two things. So they give us the dry bulb, right? And now we have the wet bulb. Okay? So the dry bulb, after we move the psychrometer, which how it's set up is you have two thermometers, and then you spin it around, okay? So the dry bulb, the slide it gives us, let's say it's at 26, okay? And if you notice, the units that they use is in Celsius, okay? Now the wet bulb, let's say it's 16 degrees Celsius, okay? Now we got to find the difference. So the difference is going to be the dry bulb minus the wet bulb, all right? So we get 10, okay? So that's our difference right now, but we're not done yet, okay? So now what you have to do is, since I'm asking for the dew point, okay, you're going to go in, and you got to be careful because they're both different graphs. So you have the dew point at the top, and then you have relative humidity. Since I'm asking for the dew point, we're going to be using the top one, okay? So what you're going to do is, you will notice that it has two sides to it, okay? Let's see if I can bring this over a little more. So at the top, it's telling you the difference, okay? And then on the side, it's asking you, it tells you the dry bulb temperature, all right? So let me get rid of this right now, okay? Because we already found the difference, it's 10. So I'm going to keep the difference equals 10, okay? So what you're going to do is, at the top, you're going to find where 10 is. So 10 is pretty much down the line, okay? Let's say 10's here. Now, we have to find on the side the dry bulb temperature. Remember, the beginning of the problem, okay, it said the dry bulb, all right, equals 26. They gave it to us. So we have to go all the way down, okay, by our dry bulb. We go all the way down. We look. We find 26. It's somewhere down here. So what you're going to do is you are actually going to go across, and you are going to write down the number that it gives you, okay? After this, I'm actually going to put up a YouTube video that shows how to calculate this. But for right now, I just want to work through it. So we go from 26, we keep going all the way across, and we go to where it matches up with 10. So you get 9, okay? And that is going to be your answer, okay? Now, let's say we did the same thing, but now we're going to say, what is the relative humidity, okay? So remember, we just did the dew point. Now we're going to use this chart, okay? And again, it's set up the same way. It's asking for the difference, and it's asking for the dry bulb, okay? But the answer might not be 9, okay? So that's the dew point, all right? So the dew point was calculated. It's 9 degrees Celsius, okay? And how do we know it's Celsius? Because that's the units it gives us. Now, let's try to find the relative humidity. All right. So now let's look at relative humidity. So let's get rid of these lines. Okay. Again, the graph is the same. It's asking for the difference. Our difference that we calculated is 10. All right. So we got to go over here. We go a little 10. We have to follow it down. Okay. But we don't know what the side is that we're starting out with. But for this problem, we do. It says that the dry bulb temperature is 26. So we're going to go all the way down. We're going to go across. And now we're going to look at what that number is that they give us. Okay. So if we follow that down, remember we're using relative 34 for relative humidity. All right. And the units that we use for relative humidity is percent now. It's no longer degrees Celsius. If you go to the bottom chart, it says relative humidity, it gives you the percent. Okay. Now, that's all we're doing right now. There's another step to this problem. We're going to be doing it on Wednesday. Okay. So right now, all you have to do is you find the difference, use the dry bulb, you match it up. You make sure that if I'm asking for relative humidity, you use the bottom chart. And if I'm asking for dew point, you use the top chart. Okay. So I'm going to look for a problem right now. Okay. So here's one right now. So I'm going to erase all this. One of the problems they're giving us is what is the dew point temperature if the dry bulb temperature, okay? So they're giving us dry bulb temperature equals 10 degrees Celsius, okay? And the wet bulb temperature equals 8 degrees Celsius, okay? So it's asking us what the dew point is. So first things first, we're going to be using the top chart, okay? That's our dew point chart. Now, the two lines, okay, the two axes, we've got the y-axis and the x-axis. They're asking us the difference and then the dry bulb temperature. So we're told what the dry bulb is, right? It's 10 degrees Celsius. So I make my little axis, all right? This is what you guys are going to be looking at. You go down to 10 degrees Celsius. It's going to be over in this area, right? Now we got to go across, but we got to find the difference. Okay. So 10 minus 8, the difference is 2. Now we go, and it's right here. So it's pretty short. And all we're doing is reading off that number. So when we match up 2 and 10, we get 6 degrees Celsius is the dew point. Okay. Now, let's say we change that up. Now I'm asking for the relative humidity. Okay. So relative humidity, we're going to do the same thing, but we're just going to use this bottom chart down here. So we look for the difference and we look for the dry bulb temperature. So the dry bulb temperature, it doesn't change. It's still 10 degrees Celsius. And the difference between the two is still 2. Okay. And the only thing that's different is the numbers inside the graph. So if I mark it down across, right, we're still going down to 10 degrees Celsius because that's our dry bulb. And then we go to the difference, okay? So we look at it. We have 10. We go to 2. And where they connect, it's 76, okay? But we don't do degrees Celsius. We look at what the units are, and it's percent, okay? So that's our relative humidity. All right. So that's the math that's involved in finding moisture in the atmosphere. Okay. Remember, Warm air can hold more moisture than cold air. That's why over the summer you have those warm, humid days, okay? Whereas if it's cold out, it's usually dry, okay? Um, so that's all we're going to be doing right now. So tomorrow, all right, tomorrow report cards are due. So as long as you're doing what you're supposed to, you should be fine. I've been converting a lot of the stuff over. I'm going to be doing it later today. Make sure you get as much assignments done as you possibly can, because after tonight, I got to submit the report cards. Okay. Don't be handing it in at like 1 o'clock in the morning. I'm not going to see it. It's going to be too late. So that's all we're going to do. Make sure for some of those labs that we've been doing, as I move over to that side, make sure for some of those labs that we've been doing, that you just take a picture of it and send it to me. Okay. I did message some of you if you were missing it, and then you sent it, and I did adjust the grades. Okay. This doesn't mean throw out the lab. Keep it safe. Keep it in a folder, just in case if we go back. Okay. And again, this is page 12 in your Earth Science reference table, both of those graphs. So I am not going to assign anything tonight. I want everyone just to get done with what they need to, so they get a good grade on their report card. Okay. That's going to get sent out tomorrow. The other thing is, tomorrow I will put up a worksheet that has to do with this. Okay. And then we're going to go over it on Wednesday. So definitely glance at it. Some of them might be a little tougher than others. Okay. But you're going to be using page 12 and page 13. All right. It's all going to be converting. You're going to use your dew point, relative humidity, and then on the other page, you're going to be converting temperature and pressure. Okay. And it says all the stuff that you need to do. But for right now, all right. So I will see you guys later. And if you have any questions, just message me. All right. See ya.